All right, hello. Welcome back. In this video, we're going to be talking about how to determine the most common ion and most common isotope for any, well, not any element actually, for most elements. So first off, in order for this to make sense, you really need to have a periodic table in front of you. I wouldn't rely too heavily on the one on the wall. Actually get one of these and use it while you're watching this video, because this is going to make so much more sense if you have this in front of you. So pause this and get that done, because I'm about to move forward as if you have already gotten it. All right? All right, cool. So we are going to talk about most common ion. Actually, let's do most common isotope first. Most common isotope is easier. It makes more sense. Yeah, let's talk about the most common isotope first. So, first off, most common isotope. I guess before we talk about that, we need to review what is an isotope. So, isotope has to do with the mass number. Right, we're talking about the mass number. When we talk about isotope notation, lithium-8. Lithium-8 is an isotope notation. Well, the 8 is the mass number. Okay, so when we say most common isotope, what I am telling you is I am telling you what the mass number is. Now, this is a trick that some of you already know, because I've seen you trying to use it on some of our earlier worksheets. But you couldn't use it yet because we hadn't covered it yet, and we weren't ready for you to start using it. Okay, most common isotope is, at the end of the day, just a way for me to tell you, hey, this is the mass number. You just have to do a little bit of work to figure out what it is. So, hopefully you put in the time that I mentioned earlier in the unit, dedicated towards getting it straight in your head, that charge is ion and isotope is mass number. Because if you can't remember those two things, then this is going to be rough for you. Ignore the two boxes that I drew on this. I drew them thinking more about most common ion, which we'll come back to in a bit. So the most common isotope is simply the most common isotope. Isotope means mass number, so it's the most common mass number. Every element on the periodic table has a most common mass number. Okay, and you can figure it out very, very easily. It is the rounded average atomic mass. So let's take this element right here. Okay, that is strontium. To get the average, to get the most common isotope for strontium, we take this red number at the bottom, which I can't read. It's 87.62. Okay, that is the average atomic mass, not the most common isotope. The average atomic mass, 87.62. Okay, and I'm going to pause so I can write that down. Okay, 87.62. To determine the most common isotope, you just round this number to the decimal point. So this is the point where you're rounding. This is the last digit. So 87.62 rounds to 88. 88 is the most common isotope for strontium. Okay, or the most common mass number. Okay? So, if we take that and we apply it to a couple other elements here, let's go with, boy, I cannot read this. Okay, boron here, I can't read what it says. It's 10.82. Okay, so its most common isotope is 11. Okay, right underneath it, aluminum is 26.9815. Well, so then the most common isotope is 27. And that's it. You just have to know that when I say, and you have to know this, you must know it, because I'm not going to help you with this on quizzes and tests. You must know. Most common isotope means most common mass number. And you can then use that mass number to figure out the number of neutrons. But you have to recognize that most common isotope means most common mass number. Okay? That's on you. You have got to memorize that. And that's pretty much it for mass number. So now let's talk about most common ion. Now, obviously, most common ion is the most common charge. This takes a little more work to get to, and I'm going to show you a shortcut, but you have to remember that metal versus nonmetal matters. What is the defining characteristic of a metal? What is it? Come on. A metal must lose electrons. It has to lose. Okay? Well, there's this neat little trick with the periodic table. Okay, and by the way, you can only determine the most common isotope. Sorry. You can determine the most common isotope for anything. You can only determine the most common ion, though, for stuff in the blue box or the red box. By the way, this is the S block, this is the P block. That doesn't really matter, but I'm probably going to start using it as reference points. Okay, everything in group 1 has one valence electron. You can draw out the Bohr diagrams. You'll find every single atom in this first column, every one of them, a neutral one, has one valence electron. Everything in group 2 is going to have 2. Now you can also see this for the first couple periods in the P block. For the rest of these, this is a lot harder to see, so I don't recommend drawing them out. But everything in 13 has 3 valence electrons. Everything in 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8, except for helium. But we're not going to worry about that right now. That means that everything has the same number of valence electrons based on its column. 1, 2, 3, 4, 5, 6, 7, 8. This is really handy because that means we can use that to figure out what the most common ion will be. Partially because we know that metals have to lose and nonmetals have to gain, but also because we know what we talked about earlier, that they're always going to take the path of least resistance. By they, I mean atoms. They're going to take the easiest option that is available to them. I'm writing a couple things down. I should probably pause while I write this. Hang on. Okay, so we can actually look at the number, at the group that something is in, and figure out how many valence electrons it has. So based on what we covered in the last video about ionization, we can figure out the most common ion for every element in the S and P blocks. Everything in group 1 has a charge of +1. Everything in group 2 has a charge of +2. The P block is slightly more complicated. Okay, over here we have a mix of metals, nonmetals, and metalloids. And so things get a little screwy here. Remember, though, that nonmetals must gain. So every nonmetal is the red charges here. Every metal is the blue charges. So everything in group 13 has 3 valence electrons. So metals are all going to lose 3 electrons, giving them a +3 charge. But nonmetals are going to gain 5 and have a -5 charge. Now, yes, I know someone has already noticed this, but I'm going to mention it anyway. There are no nonmetals in group 13. However, there is a metalloid, and we're going to come back to metalloids. For now, metals and nonmetals. In group 14, there's 4, so the metals are going to lose 4 electrons. Hang on. Yeah, that's a 4. It doesn't look like a 4, but that's a 4. Metals are going to lose 4 electrons, giving them a +4 charge. Nonmetals are going to gain 4, giving them a -4. Then +5 minus 3. +6, -2. And I didn't write this one for some reason. But then in group 17, we have +7 and -1. Okay, so now again, there's not really any metals in group 17, but there are metalloids. So we'll come back to this idea. So nonmetals are the red numbers. That's their most common ion. Metals, the blue numbers, are their most common ion. Now let's talk about those pesky metalloids. Well, what makes a metalloid a metalloid? Well, it's the fact that it kind of blends the properties of metals and nonmetals together. They're capable of either gaining or losing depending on the situation. So they actually all have 2 most common ions, and you have to report both. By the way, for this conversation, hydrogen is a metal. We're going to treat it like a metal. It's almost always +1. Okay, now this is not going to be 100% correct because, like I said before, metalloids typically trend one way or the other. Some of them behave more like metals, some of them behave more like nonmetals, but we're not covering the specifics on that, so you just need to know that all metalloids have 2 possible charges. So boron can be +3 or -5, so you report both. Silicon and germanium can both be + or -4. Oh boy, I think that says astatine. That's arsenic. Arsenic and antimony, since they have 5 valence electrons, and they can actually gain or lose, they have 2 most common ions. They can either be -3 or +5. And then, I'm not going to look again, but these 2 can be +6 or -2, and the last one down here can be -1 or +7. Now, this means that I'm never going to give you, in practical terms, I'm never really going to give you a metalloid and ask you to determine its most common ion. I will ask you for their most common isotope. That you should be able to figure out. But once you finish the worksheet, you're never going to have to really determine the most common ion for a metalloid. You're going to be told the charge by some other mechanism because there's 2 possible charges for metalloids. So, yeah, that's a little screwy. I just realized I forgot to print something, so I'm going to pause this, print it, and then I'll pull it up and show it to you. So, one moment. All right, so you should hopefully have or be about to be given this worksheet. I probably should have mentioned this before, but if you don't have this yet, pause this video and get this, because I'm going to do 2 of them with you. Okay, this worksheet is meant, by the way, ignore the big square over here. Apparently there was something in my printer. This worksheet is meant to help you practice most common ion and most common isotope. And you've heard me say this a few times, but I'm going to say it again because some of you don't listen. Complete the rows, not the columns. Do the whole row before you go onto the column. Okay, don't go down all the way and then down all the way and then down all the way and then down all the way. You will not remember what you are doing. Do the row. Yes, it takes longer. I know, it takes longer. But you learn it better this way. And you need to know how to get the most common ion and how to get the most common isotope. And you need to know which one is which. So make yourself do it the longer way. Okay, make yourself switch tasks. Okay, so for rubidium here, the first thing we're asked is the element symbol. Now, if you know the element symbol, you can just write RB. If you don't know the element symbol, you're going to have to find it, and it might take you a while if you don't know where it is on here. I'm going to tell you, though, that rubidium is an alkali metal. So how many of you remember what an alkali metal is? Alkali metals are group 1 except for hydrogen. Okay, so it is right here. Okay, so rubidium has an element symbol of Rb. Then the next column is the number of protons. I can't read it. Okay, the number of protons for rubidium is that, hopefully you know this already, this is review. You know that it is that blue number up in the corner there, which is a 37 here. So we're going to write down 37 for protons. Most common ion, rubidium is in group 1, so it's a positive 1. And most common isotope, well, rubidium has an average atomic mass, the red number at the bottom of the cell, of 85.4678. We only care about the first decimal, 85.4 rounds to 85. So 85.4 stays 85, so 85 is the most common isotope. Okay, now I am going to do, I don't think I mentioned, I'm going to do helium. We're going to do 3, actually. I'm going to do helium. Helium is He, has 2 protons. It's all the way over here. Okay, its most common ion is 0. Okay, and that is true for all of the noble gases because they are the special word we learned last unit. Okay, that word is inert. Because they are inert, they will not react, which means they cannot ionize because they cannot react. So their only possible charge is 0. Okay, so helium's most common ion is 0. Its most common isotope, though, is going to be 4 because 4.00 is going to round to, 4. And then I want to do one metalloid. So we're going to jump down to astatine because astatine is a metalloid. So astatine, that's right here, kind of right in the middle of the P block. I'm pointing at arsenic. Hang on. No, astatine is down here at the bottom. Okay, astatine is an element symbol of At. Its atomic number, the blue number, is 85. And its most common ion, because it is a metalloid, it has 2, and you need to write both. It's going to be both -1 and +7. So put a slash between those. -1 / +7, or +7 / -2. But you need to record both of them. And then its most common isotope. This one's really easy. You'll see this a lot if you look at the last few elements on the periodic table. There are a lot of them that aren't decimals. They have a number that is in parentheses. That's because this element hasn't really, we don't know enough about it. This is approximately what we think the mass number is. So you just write down that number, no rounding required. So 210. Okay, and then that's it. That's 3. So I'm not going to do any more. I don't want to give you any more answers. The key for this is linked in Canvas already. Go through and complete this. Check it when you're done. I think this is the first time this has come up for this class, so I do want to mention the key is actually in the same Google Doc. Google Doc has added this tabs feature, if you haven't noticed. So on the left-hand side, it has 2 tabs listed. Hopefully, when you open it, you may have to click something to pull that menu up. The second tab is the key, so you can click on that and it will show you what the answers are for all of these. Yeah, that's pretty much it. So I'm going to sign off here. Have a wonderful day, night, afternoon, evening, twilight, I don't know. And I will see y'all in the next video.